All right, get ready to dive into some physics that will really make you think. Today we're tackling holism and non-separability, and knowing you'll love this. It even dips into some pretty deep philosophy. Our guide for this deep dive, the Stanford Encyclopedia of Philosophy's entry on, well, holism and non-separability in physics.
Oh yeah, that's a classic. When things get weird in quantum mechanics, that's always a good place to start.
For sure. But before we get too deep into all the quantum craziness, I think we should start with definitions. Like, what do we even mean by holism and non-separability? They kind of sound like the same thing, don't they?
Yeah, they are related, but there's a subtle difference. It's like imagine trying to figure out how a flock of birds flies. A holist would say that you can't really get it just by studying each bird separately. The patterns they make, the formations, how they move as one, those are like properties of the whole flock, not just each bird doing its own thing.
So holism is about the big picture, not just the tiny pieces. Makes sense. So then where does non-separability fit in?
Nonseparability goes further. It says even if you figure out how those birds interact, you still don't get the whole picture just by adding those interactions up. Like the birds are basically fundamentally linked. You can't take one out and fully describe it with the whole clock.
So non-separability is like saying they're not just interacting, but kind of inherently bound together.
Exactly. Now, that's a bit abstract, I know, but there are different kinds of holism that show up in physics.
Oh, tell me more. What kinds of holism are we talking about?
Well, there's one called methodological holism. It's a bit more practical. It suggests that some systems, well, you got to study them as a whole, not just their parts, like take a superconductor. Trying to get its properties just by looking at each electron would be like, I don't know, trying to read a book by studying the ink, like its chemical makeup. You got to look at the whole thing working together.
So it's partly about practicality. Some things are just too complicated if you break them down too much.
Right, but then you have metaphysical holism, and this is where it gets really interesting, especially for a philosopher like you. This type of holism says that some wholes have properties that aren't just determined by their parts, even with how they relate. It's like saying a flock of birds has like a flockness that isn't just from how each bird flaps its wings and all that.
Okay, I could see how that'd get a philosopher thinking. Is like, are there really emergent properties? Is the whole truly greater than the sum of its parts?
Exactly, and that idea has some serious implications for how we understand reality itself. But to really mask that, we need to see where non-separability shows up in the actual physics world.
Well, don't keep me waiting. What are some real-world examples?
Okay, let's start with the one that probably gives most physicists a headache and makes science fiction writers super happy. Quantum entanglement. Yeah, quantum entanglement. It's the kind of thing that even physicists who've seen it all still find a bit strange. It's when two particles are linked up so that no matter how far apart they get, their properties are like correlated. It'd be like if you flipped a coin here and someone flipped an identical coin, I don't know, on Alpha Centauri at the same time, and every time yours landed heads, their landed tails. That's kind of the idea with these entangled particles.
Wait, so that sounds like they're communicating faster than light. Didn't Einstein hate that idea?
He did. He called it a spooky action at a distance, I think. He was pretty skeptical. But the experiments, they show entanglement really happens. Like when you measure one entangled particle, it instantly affects the other one, even light years away. And it's not like they were pre-programmed or something. It's like until you measure one, either of them actually has a definite state.
Okay, now I'm starting to see why physicists get headaches. It kind of messes with some basic stuff we thought we knew about the universe. Like things can't affect each other faster than light can travel, right?
It definitely shakes things up. And for a philosopher like you, it has some pretty mind-blowing implications too. Think about causality, for example, like cause and effect. We tend to think of it as A causes B, B causes C, nice and linear. But if things can be instantly connected across, like huge distances, that linear view gets a bit messy.
Right, yeah. If stuff can be linked across space and time like that, how do we even know what caused what? It'd be like untangling, I don't know, a cosmic knot.
Exactly. And then there's the whole question of free will. Like if everything's basically interconnected, if our actions can be influenced by something happening, I don't know, across the galaxy, does that even leave room for a real choice?
It definitely makes things more complicated. I mean, philosophers have been arguing about free will forever, but this throws a whole new wrench into the works. Like, are we actually independent, making our own choices? Or are we all just part of this cosmic web, reacting to everything around us?
That's a question that, well, both physicists and philosophers will be thinking about for a long time, I think. And it's not just those big questions either. Non-separability also affects how we see ourselves, our place in the universe. If everything is connected, then the lines between I don't know, self and other, individual and collective, they get kind of blurry.
So it's not just particles being entangled. It's like our very identities are entangled with the world around us.
Exactly. And that changes how we think about ethics, how we relate to each other, even our responsibility to the world.
Yeah, like non-separability is kind of pushing us towards a more holistic view, right? Everything's connected. Our actions have these ripple effects that go way beyond us.
Exactly. And that shift in how we see things, I think that's one of the most important things these mind-bending physics concepts can offer. They make us think about the world in a new way, consider how everything's linked up. It challenges how we used to think, but it also gives us a chance to understand ourselves and the universe in a deeper way.
Okay, my brain is definitely feeling a bit stretched. But before we go too deep into philosophy, let's get back to some physics. I mean, quantum entanglement's the famous one, but there are other things that suggest this interconnectedness might be a basic part of reality, right?
Absolutely. There's, for example, the Aharonov bomb effect. It shows how a magnetic field can actually influence electrons even if they don't go through the field. It's like the electrons know the field's there even when they're physically separated.
Okay, that sounds pretty wild. You mentioned it earlier, but can you explain that a bit more? How does that, like, point to non-separability?
Okay, picture this. You've got a solenoid, which is basically a coil of wire, right? And it has electricity running through it, creating a magnetic field inside the coil. Now, imagine you shoot a beam of electrons past the outside of that coil, so they never actually touch the magnetic field directly.
So, like, the electrons are going around the magnetic field zone.
Exactly. And classical physics would say, well, they're not going in the field, so their paths shouldn't change, right? But here's the weird part. They do change, even though they never actually come into contact with that magnetic field. It's as if they're affected by like the overall structure of the electromagnetic field, even if they're in a spot where the field strength is zero.
So they're sensing it's there even though they're not directly interacting with it. Like they're aware of the magnetic field's potential, not just its actual strength at a point.
You got it. That's what makes the Aharonov bomb effect such a strong example of non-separability. It suggests the electron and the electromagnetic field aren't truly separate things. They're part of this bigger, interconnected system. It's like kind of like those birds in a flock. Even if one bird's not directly next to another at some moment, it's still part of the whole flock's movement and patterns.
I see. So both quantum entanglement and the Zaharonov bomb effect, they suggest this idea of separateness, like how we usually think of things as distinct and independent. Maybe that's not really how the universe works at a fundamental level.
Yeah, that's the big idea. And it could totally change not just physics, but how we understand reality itself.
My mind is officially blown. But I feel like we're just scratching the surface here. Like there are even deeper, more mind-blowing implications to explore.
You're absolutely right. We've only just dipped our toes into the philosophical rabbit hole that non-separability opens up. But maybe we should take a break here, let our listener process all this before we dive in any deeper.
Okay, welcome back. After that last part, I feel like I need to go meditate on the interconnectedness of everything for a while, maybe with like a physics textbook and a cup of tea.
Well, if you're looking for more mind-blowing stuff, I've got something that might just, send you down a real philosophical rabbit hole, ready to tackle the idea of time itself.
Hit me with it. I'm all about questioning reality at this
All
point.
right, so think about how we usually think about time. It's like a line, right? Going from past to future, it makes sense. It's how we experience things, and a lot of science is based on it. But if this non-separability thing is really fundamental, like if everything's connected in ways that go beyond space and time, then maybe that simple picture of time isn't quite right.
Okay, yeah, if everything's interconnected, then maybe the past, present, future, they're not so clear-cut as we think.
Exactly. Non-separability suggests that the lines between those moments might be a lot blurrier than we think. Like maybe things in the past can still affect the present, and what we do now is shaping the future in ways we don't even realize.
So instead of time being like an arrow going one way, it's more like, I don't know, a cosmic soup with everything kind of swirling together.
That's a pretty good way to put it. And some physicists and philosophers are actually exploring that idea. They say time might be what they call an emergent property. Like it comes from a more basic reality that's actually timeless.
Whoa, hold on. Emergent time. So you're saying time isn't like a basic part of the universe at all. It comes from what?
I know, it's hard to imagine, but the idea is that time might emerge from how we see things, how we organize our experiences within this interconnected web of well, existence. It's like, imagine a tapestry. All the threads are woven together, representing all the events in the universe, right? We experience time by moving along those threads. But the whole tapestry, it just exists without a clear past, present, or future.
Okay, that kind of helps. But my brain is still bending. So if time is emergent, does that mean things like cause and effect, free will, do they just break down completely?
That's where it gets really philosophical. Like, if the future isn't fixed, if it's always being shaped by this interconnected web of everything, does that mean there's more room for choice, for agency? Does it change how we see responsibility? These are questions people have been thinking about forever, but non-separability, it adds a whole new layer of complexity.
It's like non-separability makes us rethink the most basic things about, well, about existing. I think philosophers and physicists will be debating this for a long time to come.
Yeah, definitely. But that's what's so exciting about it. It makes us face the limits of what we know and embrace the mystery of the universe. It might be way stranger and more amazing than we thought.
Well, I can definitely say this deep dive has lived up to its name. We've gone from definitions of holism and non-separability to crazy examples from quantum mechanics to even questioning what time is. I'm feeling a little overwhelmed, but in a good way. Like my brain just expanded to fit a whole new universe of possibilities.
That's what these concepts do, They push us past our everyday thinking and help us see this profound interconnectedness of everything. And maybe, just maybe, by thinking about all this, we'll appreciate the world around us even more, how delicate and connected it all is.
That's a great point. And on that note, I think it's time to wrap up our deep dive for today. But remember, the exploration doesn't stop here. Keep questioning, keep wondering, and keep diving deep into the mysteries of the universe.
And remember, everything is connected. So as you go about your day, think about how your actions ripple outwards, how you're part of this vast web of existence.
That's a beautiful thought to leave us with. Thanks for joining us, and we'll see you next time on The Deep Dive.